Before we start discussing NoSQL, let's discuss what are the challenges we are facing with traditional RDBMS systems. RDBMS have increasingly failed to meet the performance, scalability, and flexibility needs that next generation data-intensive applications requires. So what do we mean by scalability and flexibility? Scalability. Users have to scale a relational database on powerful servers that are expensive and difficult to handle. And if you scale a relational database by distributing it on multiple servers, then handling table across different servers is difficult. And in flexibility, SQL Server data has to fit into tables anyhow. If your data does not fit into table, then you need to design your database structure that will be complex, and again, it will be more difficult to handle. There is no flexibility in traditional RDBMS system. So what is NoSQL? NoSQL, which stands for Not Only SQL or No Structured Query Language, is a database system which is employed for managing the massive collection of unstructured data. NoSQL solves two problems of scalability and flexibility. It is important to note that NoSQL and non-relational data are not the same thing. So NoSQL database can be used for both relational and non-relational data. Many customers of Azure Cosmos DB use this NoSQL database to store relational data. Cosmos DB SQL API also supports SQL-like queries. And as far as scaling is concerned, scaling is much cheaper for NoSQL database, because in NoSQL we can scale horizontally when a relational database had to scale vertically. Now let's discuss what does it mean by vertical scaling or horizontal scaling. Vertically scaling means that you are increasing the load on a single server by adding more and more RAM and CPU. Horizontally scalable involves adding more server to process request. As we discussed, because of global distribution, horizontal scaling was very difficult for relational databases. Therefore, relational database use vertical scaling, means getting a better and bigger machine for their database engine. But vertical scalable has a limit. You can't just keep adding more and more RAM and CPU in a single machine. But scaling is much cheaper for NoSQL database, because you don't need to scale up. You can have many cheap machines and scale your database horizontally. In a traditional database, where data is placed in a table and data schema has to be designed before the database is built, in contrast, NoSQL database do not rely on these pre-built schema structures and use more flexible approach to data model. So for example, if you are creating a new application and let's say you need to store information about an order or maybe a customer who placed that order in a relational database. So you will first need to create a table with a fixed schema and then predict all the columns you want to have for the order, as well as a person who is putting that order. So for example, you need to know the first name, last name, email, and city, state, and etc. all other information. And then you need to design order detailed table with all required columns. But this is not the case for a NoSQL database. In NoSQL database, the data is not saved in tables. For example, instead of creating table named order and adding columns into it, you'd create a JSON structure for the object. You don't need to define the schema first. It makes it very easier to update the application and data based on the requirement changes. So back in the days, earlier we used to have a good understanding of the data structure when we start our project. But nowadays in most of our projects, we don't have a clear understanding of the data structure. So NoSQL database are a good choice of these kind of project where either we do not have a clear requirement, or where we are expecting that requirements can be changed very soon or very frequently, and we do not have a very clear data structure understanding. So these databases are designed to handle unstructured data. Alright, so let's take another example here. So this is an order, and it has a date, it has a customer. So in transaction, you can simply store in JSON document. You do not need a table or a relationship with other tables, or you do not need to point it to something else. You have all your information in one JSON document, and it is easy for system to handle information here. It is easy to add or easy to remove or delete any entry from this JSON document. And I would like to point here that if you notice, it is not enforcing a schema here. So you can have one entry of products that has a name and quantity, and then the second product has the name, quantity, and status field. So this status field can exist, but it is not required to exist. Some of this field may have status and some may not have. Similarly, you can also add or delete field as per your requirement. You can have basically the different schemas for the same piece of data, and it's up to your application to be able to handle that. So let's discuss some of the use cases of NoSQL. NoSQL databases are increasingly used in big data and real-time web applications. NoSQL databases are typically used for scenarios where you have a large amount of data, and the relationship between that piece of data is not very important, and you can change it frequently if required. And as I said, if data has a high likelihood of changing over time, then you should consider NoSQL database for your application needs. So now let's talk about some of the limitations of NoSQL database. Schemaless is an advantage, but it can also be a disadvantage, because now you are not enforcing schema. Your important fields may be missing. Maybe you miss the first name or the phone number, or maybe some other important field. There is no normalization in NoSQL. Now you do not have separate master or dimension kind of tables. Everything is saved in one JSON file. That means more duplicate and redundant data. It also means that now you could have an inconsistent and inaccurate data. For example, now you can insert same record twice. There is no check, and this can lead to conflicts. And NoSQL database is also missing features like store procedures or functions or views or security, like row level locking and so many other security features. So this was the introduction of NoSQL database. Now we understand that how NoSQL is more important or more usable in nowadays application scenarios where we do not have a clear understanding of our data structure, or we are assuming that our data structure may change very soon or very frequently. In those cases, NoSQL is generally better or preferred choice over RDBMS or traditional databases. Thank you. Alright, in this lesson we will consolidate some of the points we discussed in the previous lesson, because from certification point of view it is important for you to understand difference between SQL and NoSQL databases. So as we discussed, SQL databases are relational databases, which refers to columns, rows, tables with keys. In this database, each row represents one specific entry. And NoSQL is an acronym. It stands for not only. So not only relational, but also utilize non-relational or distributed databases. So SQL uses relationships between the data, and NoSQL uses non-relationship database. SQL has a very static, a very rigid schema, and NoSQL is dynamic. The schema can change, or sometimes it doesn't even require a schema. It is more kind of representative of a family of information and not a very specific entry. The type of information is dynamic in nature, and this could be comprised of like tables or graphics or files or JSONs or other types of data. Because of the structure, SQL databases are designed for complex queries, and since it is not a fixed schema, it is not as well suited for handling complex queries. Common languages for SQL may be like SQL or MySQL, Oracle, PostGREs, and typical NoSQL languages are MongoDB, Redis, or HBase. SQL has a vertical scaling. That means you can add more and more power to your database, to your single machine. And NoSQL uses horizontal scaling. That means that since the database is spread out over several different servers, you can just add more servers or more machines along the way. So basically in vertical scaling, you add more horsepower to the server, and in horizontal scaling, you add more servers to the database. And make sure you don't get confused SQL DB with the SQL Data Warehouse. SQL Data Warehouse is different because SQL Data Warehouse can utilize parallel processing and can scale horizontally also. So SQL is row oriented, where you have a record represented by a row, and NoSQL is multi-modal oriented. SQL traditionally use tables, and NoSQL use sometimes called collections. Now SQL is limited in use when we have big data, but NoSQL is great for big data. For the same reason, as I said, we can scale as much as we want through horizontal scaling. But in SQL, there is a limit because of vertical scaling. You cannot just keep adding more CPU and RAM and memory and disk and everything into one machine. There is a limit where machine can handle the data. There is a bottleneck. So typical use case of SQL are transactional systems. So, product or order or student management, that sort of thing. And NoSQL use cases may be like IoT data or chat messaging or fraud detection of data kind of situations. So I hope by now we have good understanding in difference between SQL and NoSQL databases. Thank you. In last few lessons, we discussed about NoSQL database, and we discussed how NoSQL database is different from RDBMS or traditional databases. In this lesson, we will talk a little bit more about NoSQL databases, and we will discuss 4 main type of NoSQL databases, and we will go a little bit in more details about these databases. So we have 4 main type of NoSQL databases: document store, graph, key value, and white column. So let's discuss one by one. So the first one we are talking about is the key value store, which is very simple database to store data in the form of key and value. So if you look at the example here, we have person name as a key, and person phone number as a value. And it is very simple, just name and the value. Value can be anything. It can be a string, it can be a JSON, blob, or any other kind of object. And since this database is very simple, it is also very quick to query. It is very simple to query, and the result is also very fast. And the use case scenario may be, you can store the user profile and session info of the website, block comments, telecom directory, IP, forwarding tables, shopping carts, and so on. And there are many key value type of NoSQL database. First of all, we have the Cosmos DB table API. You can store these values. So Cosmos DB table API is the prime version of key value store in one sense. And we have many database examples which store these key value type of data, like Cosmos DB table API, Redis, table storage, Oracle NoSQL database, and so on. And then next we have is document store database. So document store database uses a document oriented model to store data. It is similar to key value database because it also uses a key value approach. And the difference is that value in a document store database consists of semi-structured data, also known as document oriented or aggregated database. A document store database stores each record and its associates data within a single document. Each document contains semi-structured data that can be queried against using various queries and analytical tools of DBMS. The document in document store are usually XML or JSON, but some DBMSs use other languages such as BASIN or YAML also. And here we have one simple example of document written in JSON. Document store database can be used for wide variety of use cases. They are ideal for content management system, blogging platforms, and other web applications. They are also well suited for user-generated content such as blog comments or chat session, tweets, ratings, etc. Document store are also great for providing real-time analytics and other reporting features. And we have some examples like Cosmos DB, MongoDB, DocumentDB, CouchDB, MarkLogic, OrientDB, and so on. And then we have column store. In column-oriented NoSQL database, data is stored in cells grouped in columns of data rather than as rows of data. Columns are logically grouped into column families. Column families can contain a virtually unlimited number of columns that can be created at runtime. Read and write is done using columns rather than rows. Column store works in similar fashion to relational database in that they have rows, columns, and tables, or we can say column families. However, these work differently in column store databases. In a column store databases, the columns in each row are contained within that row. That means each row can have different columns to other rows. They can be in different order. They can even have different data types. And here is the example to demonstrate that. A column family contains 3 rows. Each row contains its own set of columns. And this method of storing data can be extremely quick to load and query. And this columnar databases can also store massive amount of data, and they can be scaled easily using massive parallel processing (MPP), which involves having data spread across a large cluster of machines. Some of the use case of a column store database may be like sensor logs, which is generally we use in IoT devices, or we can have the geographic information reporting system, time series data, logging, and other very heavy applications. And some of the examples may be Cosmos DB, Bigtable, Cassandra, HBase, and Vertica, etc. Now, Graph Store or Graph Database focuses on how data relates to other data points. Graph databases are an excellent choice for working with connected data that contain lots of interconnected relationships. In fact, graph databases are much more suited to displaying relational data than relational databases. So for graph databases, we first need to understand the type of information stored. Graph consists of node and edges. A node is a specific entity or piece of information, and an edge simply specifies the relationship between two nodes. You can think of edge as the line and the node as the block of information. And here we have the basic example of how graph database stores and present data. So for example, we have these name of people like Jack and Annie and Sam. So Jack, Sam, or Annie, these are the nodes. And the relationship between these two, like a friend, this is the edge. And these kind of databases are used when you have a set of data that has a lot of interconnected relationship between the different nodes inside of that data. When you think of graph databases, think about social network or real-time product recommendations, or maybe a fraud detection, access management, network diagram, things like that, where you have all of these different connections between the nodes inside of the database. And some of the examples of graph database like Cosmos DB, Gremlin API, or BlazeGraph or OrientDB, etc. Now, some of these databases include features or characteristics of more than one data model. These databases are usually categorized under one or both of the models they use. They can also be referred to as multi-modal databases. Some examples of multi-modal databases may be like OrientDB, which combines a graph model with document model. We have RangoDB, which uses the key value or document and graph models. Or we have Virtuoso, which combines the relational, graph, and document models. So I hope now we have some familiarity of different kinds of NoSQL database and how they differentiate from each other, and in what kind of situation which database we should prefer to use. Thank you. In some of previous lessons, we discussed in detail about NoSQL concept and NoSQL different types of databases. Now, in this lesson, we will talk about managed NoSQL offerings by Microsoft Azure. We are going to look into these NoSQL offerings in detail in rest of these modules. So first we can have, let me start marker here. So first we have NoSQL offering as a IaaS, infrastructure as a service, in which Microsoft will provide us the virtual machine, and then we can store or install NoSQL database of our own choice. So if you see, technically this is not an offering by Microsoft, because Microsoft is just providing us the virtual machines, and it is we who are installing NoSQL, and we will be maintaining and we will be doing all the maintenance and upgrade work for NoSQL. Now, another managed option we have in the platform as a service by Microsoft. In this case, this is managed service. Microsoft will take care of all the management and the upgradation part. So as we discussed, PaaS is technically Azure NoSQL offering. So in the rest of the module, we are going to discuss about the PaaS offering. Now in this, we have three different offerings. One is Azure Storage, and then Data Lake and Cosmos DB. Azure Storage can be used to store unstructured data in very cheap rate. So we can just dump all our data into Azure Storage in very cheap rates. And then we have Data Lake, which is built on top of Azure Storage, but Data Lake has many advanced features, and we will look all of these advanced features in detail. And then we have Cosmos DB, which is Microsoft's own NoSQL database, and earlier Cosmos DB used to call as a document DB. Now let's talk about a little bit more of these databases here. So Azure Storage account, this is cloud service managed by Microsoft that provide storage that's highly available, secure, durable, scalable, and accessible from anywhere in the world over HTTP or HTTPS. And there are 4 different services offered by Azure Storage. These are the Blob Storage, Table Storage, File Storage, and Queue Storage. Technically, File Storage and Queue Storage are not exactly NoSQL database. Generally, we consider Blob and Table Storage as a NoSQL database. So Blob Storage is an object storage solution that is optimized for storing massive amount of unstructured data, and this unstructured data can be of any type, like text files or documents or binary data, anything like image or videos. In fact, you can store the virtual machine images or maybe the database backup. So you can dump any type of data and any volume of data into the Blob Storage. And this is cheap, but this is not very fast, and this cannot be generally used directly in big data scenarios. And then we have the Table Storage. Now we will discuss about file storage, but basically the Blob Storage and file storage allows you to store unstructured data. For structured data, meaning that data that can be broken down into fields, Table Storage is NoSQL store that allow you to store massive amount of structured non-relational data. So with Table Storage, you can store flexible data sets in a schema-less design. There's also now a premium version of Table Storage, and that is called Cosmos DB. So Cosmos DB is a premium version of Table Storage. And then we have the File Storage, which is very similar to Blob Storage. And this file storage allows you to store a variety of files, but file storage supports the SMB protocol. Now this is important. This is how this is different from Blob Storage. SMB protocol, which means that you can attach this storage to multiple virtual machines for read and write access. And it shows up in your drive later, just like the file shares you're used to. So if you have experience of, for example, mounting a Google Drive or OneDrive with your laptop, you see a separate drive letter for these cloud-based services. So file storage is also can be used that, and that's what is called as a SMB protocol. And then we have the Azure Storage Queue. And queue storage is used to store and retrieve messages. In this module, we are going to discuss mainly Blob Storage, because Blob Storage is in the course, in the syllabus of certification. And we will also discuss a little bit about Table Storage, because Cosmos DB is basically the premium version of Table Storage. So to understand Cosmos DB better, we should understand Table Storage also. And then we can see the contrast both of these storages have in between. Now let's discuss a little bit about Cosmos DB, and we are going to discuss this in detail in this module. But just to give you a little introduction, Cosmos DB is Microsoft's globally distributed multi-modal database service. Cosmos DB offers multiple APIs, or I should say the 5 APIs, the SQL API, Table API, the MongoDB API, Cassandra API, and Graph API. And that is why it is called as a multi-modal database. Let's see what it means. We had, for example, the 4 categories of NoSQL databases. So if you want to store your data as a JSON document in Cosmos DB, you can use SQL or MongoDB API. If you want to store a key value pair, you can use the table API of Cosmos DB. So Azure Cosmos DB Table API is a premium offering for Azure Table Storage. And we will talk about this API in detail in this module. But if you're planning to store your data as a wide column, you can use Cassandra API. And if your data is stored as a graph, you should use the Gremlin API, or you can also say as a Graph API. So basically the point is, we discussed that there are different types of NoSQL databases, and Microsoft has designed the Cosmos DB to accommodate all of these NoSQL databases. So if you are currently working on premises in any of those NoSQL databases, you can basically migrate to Azure in Cosmos DB, and Cosmos DB has API to support any of your NoSQL database. Now let's discuss a little bit about the data lake. Data lake is a repository for large quantities and varieties of structured or unstructured or semi-structured data in their very native format. So you can think of Azure Data Lake as a big container, a very big container. You can throw as much data as you want into your data lake, and later whenever you are ready, you can query it. And this has many advantages over Azure Storage, and it is important to understand those advantages, and we are going to discuss that in detail in our module. So I hope by the end of this lesson you have at least some clarity that how your NoSQL database can fit into Azure NoSQL service offerings. Azure has different service offerings, and we are going to discuss all of those in detail in this module. But the purpose of this lesson is to just aware at the very high level, at the helicopter view, to look at the all possible services can be used for NoSQL. Thank you. In this lesson, we are going to talk more about Azure Storage. So the storage account is the top level container for various storage services in the Microsoft Azure, like Blob Storage, Table, File, and Queue. And we already discussed a little bit about these services in previous lessons. But there is another premium storage called VM Disk. And this stores the virtual machine disk used by the infrastructure as a service VMs. And the disks are actually stored in the page blob in the blob service. So we will learn in this module that there are actually different type of blobs, and one of the blob is the page blob, and this store in page type of blob service. So basically all of these 4 different types of storage reside within the same storage account. You don't need to create a separate account for all of these services individually. And we will see that during the demo. But before that, let's first discuss the attributes that are common to all services in storage account. Storage is a worldwide service managed by Microsoft that's highly available, secure, durable, scalable, and accessible from anywhere in the world. So what does that mean? Let's discuss that. So when we say the storage service is highly available or durable, what does that mean? That means that your data is stored redundantly, so it's safe in the event of hardware failure within the data center. You can also choose to replicate your data across data centers or geographic regions for true disaster recovery. And we will look at these options while we're doing the demo of Azure Storage. And then our storage account is secure. And Azure Storage is secure in that all data returned to the service is encrypted. You can even use your own encryption key to encrypt blob or file data. You can enforce that the data is only accessible over HTTPS or only from a very specific IP range, so it can only be accessed from your enterprise network. Or you can configure Azure Storage so it's only accessed through a virtual network in your Azure subscription and not in general from internet at all. You can also extend that secure channel all the way to your own premises network using a private endpoint. So you can provide fine-grained control over what you have access to the storage account into your stored data. And we will look at all these security features in our module. And then we have scalability. Azure Storage is scalable because you have got access to all the underlying resources available in the cloud. Most of the Azure storages are scalable, but Azure Storage, especially when we talk about the blob, it is meant to store a big data. It's meant to store the data irrespective of the volume or the type of the files or the data. It can scale as much as you want. You can keep adding data into blob service and scale is almost unlimitedly. And then we have cost effectiveness. So Azure Storage is also relatively very inexpensive when we compare to hosting and managing a storage solution within your own enterprise, within your own on-premises infrastructure. This alone feature make Azure Storage a very compelling reason to move your data to the cloud. There are different factors that influence the cost, like the performance tier that determine things like latency or throughput or the access tier for the blobs. So you choose the tier depending on how often you need to access the data. And so there are opportunities for significant savings when it comes to things like archiving the data. We will look at the factors that go into pricing your storage services later in this module. And there's also an option to monitor your pricing, your ongoing cost to your storage service. So as I said, there are different tiers. And if you choose to archive data, which will be very cheap, if you want to very frequently access your data, that will be relatively less expensive, less cheap. So there are different flexible cost related options you have in Azure Storage. Now, in terms of accessibility, Azure Storage can be reached from anywhere in the world over HTTP or HTTPS. There are mature REST APIs that allow you to expose and protect endpoints to your data in variety of languages like .NET, Java, Node.js, Python, Ruby, PHP, and many other languages. It also supports PowerShell or Azure CLI, or I should say Azure Command Line Interface. So there are a variety of ways to interact with your data. And in addition of that, Microsoft also provide some free tools like Azure Storage Explorer or AZ Copy to make it easy to manage your storage account and move data into it or out of it easily. Option for hot or cool. And this is the oldest storage account type, and it supports deploying with classic deployment model as well as with the resource manager model. And this storage type only use the resource manager model. So you might need to use this type to integrate with the virtual networks or virtual machines deployed with the classic deployment model. And this storage account service use the REST APIs The storage account service REST APIs are versioned. And if you have your existing account in version 1 storage, it can easily be upgraded to version 2 storage to take advantage of all the latest features and storage cost savings. And you can do that upgrade from within the portal or using PowerShell or Azure CLI also. All right, we are back to portal, and next account kind and the last one we have is the Blob Storage. Now let's discuss a little bit more about this one. All right, so this is the last one, Blob Storage, and this is also a legacy type. Is the Blob Storage account type. So obviously it's not going to support file, disk, table, or queue storage. It only supports the blob one, and it can only store block and append blobs. So it does not support the blobs either. And this account type is very similar actually to general purpose version 2 type, in that it support blob access tiers. And if you want the latest features of blob storage, like hierarchical namespace support, Microsoft recommend actually to using general purpose version 2 type when you create the new storage account instead of creating this blob storage account. So we are back to portal, and once again, general purpose version 2 is the latest one. It has all the features, and this is recommended by Microsoft. And unless you have any compatibility issues, or even if you have existing accounts on version 1 or blob storage, you can migrate those accounts to version 2 storage. So let me choose version 2 here. All right, so we covered all three types of account types in performance standard. Now if we go to the premium, we have version 2 and version 1, which we already discussed. But now we have two more types of account. We have blob storage and we have file storage. So let's discuss both of these accounts now. So blob storage account type is optimized for high transaction rates and single digit storage latency. It stores the blob data on solid state hard drives in order to provide the higher throughput. And blob storage only supports blobs and append blobs, and does not support storing page blobs. But as I mentioned earlier, version 2 storage account allows for storing page blobs on a premium tier. And then blob storage doesn't support tiering for hot or cool or archive access tiers. And it also does not support disk, table, or queue type of account storage. But if you need high throughput with low latency, it's suitable for workload like analytics, where a lot of small write operations are pushed to the cloud every second. Processes that required constant editing, like data transformations, where data is constantly being modified and converted. It's also good for interactive workloads like e-commerce and mapping applications, where data may not be accessed frequently enough to justifying caching it, but it needs to be displayed very quickly when it is needed. And all these are some of good use cases for blob storage. And this brings us to the last storage type, that is the premium file share offering. And this provides higher performance and lower latency than the file share provided by general purpose version 2 storage account. Besides being backed by the solid state drives, one of the other way that file storage provides a high performance is through IOPS bursting, providing up to 3 times the input-output operations per second. And this basically works on a credit system. When your file share is not meeting its base IOPS usage, it accumulates credits that can be used to provide more IOPS during periods of peak usage. Another difference between premium file shares and the file shares in version 2 storage account is that premium file shares are built based on the size that you provision. So regardless of whether or not you actually fill the share with data, you can provision premium file share up to 100 terabyte in size. And that size limit is true for standard general purpose version 2 and version 1 file shares also. Alright, so we are back to portal now, and we discussed all types of account kind now, and we can choose back standard, and we are going to move forward with the general purpose version 2. And I know it may be a bit confusing, seeing all these permutations and combinations of different options provided here. But in general, as Microsoft suggests, you should use standard unless you need premium service. And version 2 is the most commonly used account kind we use. So unless there is a special requirement, you should move forward with this configuration. But I'm going to upload the PPTs, and it has the notes, and you can just play around here with choosing different options and look at what options available with standard and premium and so on. And if required, you can use the PPT slides and look at different configurations available for different performances. Now next we are going to discuss the replication. And again, this is a big topic. I want to go into detail to make sure you understand all of these replications and differences. And at least the replication is important from certification point of view also. So I'm going to start with the next lesson. Otherwise, this has already become a very lengthy lesson. So next lesson will be dedicated for understanding replication. Thank you. Alright, so in this lesson, we are going to learn one of the very important concepts of Azure, and that is replication. It is so important, and that's why I decided to record the replication in a separate lesson, so that if required, you can go ahead and just refer this particular lesson once again. And it is important not just from certification point of view. You're definitely going to see few questions based on replication concept, but in general also it is important to understand how we have different replication options within Azure and how they are different from each other. So storage account replication is about protecting your data from unplanned events like hardware failure or network outage or maybe natural disaster or anything which brings Microsoft Center down from working condition. Now, how you choose or replicate your data also impacts the service level agreement for storage. So for example, if you have not chosen to replicate your data in secondary region, and for some kind of natural disaster happen and your primary region goes down, then you cannot ask Microsoft to give your data back, because now it's your responsibility to make sure you replicate your data properly according to your business needs. So your data is always replicated in primary region. You cannot even change that. So all you can do is you can just expand on that with other options. And basically, generally there are three categories that group the replication options. First is redundancy in the primary region, redundancy in the secondary region, and read access to data in the secondary region. So let's start with the redundancy in the primary region first. Alright, so first redundancy option we have is locally redundant storage, LRS. Now let's try to understand about Microsoft centers. So we have, let's say for example, region A and region B. Both region A and region B are separate from each other from maybe hundreds and thousands of miles. So region A may be like West US, and region B may be like East US. So when we were creating our storage account, you remember we choose the location and we choose the West US. So maybe region in the West US, and if we choose any other location, that may be a separate region. And obviously purpose for that, if in case of natural disaster, if something happen and the whole region A become down, we still have region B where we can have our replicated data. Now within region A, it is divided into different availability zone. So for example, this is availability zone 1, this is 2, and this is 3. So these availability zones are in the same region, but they still exist as a separate building. So all 3 availability zones will have different networking, different cooling systems, different security, different utilities and all. So if one availability zone goes down, it does not affect other availability zones. They will keep working as they are. Now within one availability zone, we have multiple hardware racks. So for example, this may be one rack, and this may be 1, this is 2, and this is 3. So there may be 3 different racks, for example. So your data is saved in one hardware rack and it is replicated to another hardware rack here. So if something happens to one hardware, if this goes down, then your copy of data is still available in this hardware rack, which can be made available if required. Now if something happened to this whole availability zone, if for some reason if this goes down, then both this and this copy of your data will go down and your data will not be available. So in locally redundant storage, your data replicate within the same availability zone into different hardware rack. Now if you understand this concept, then understanding all other regions will be very helpful. So let's go to the next one. Next we have is Geo Redundant Storage. Now as we discussed, in the one region we have different availability zone, like this is one availability zone, this is second, this is third. In Geo Redundant Storage, our data is copied not just within one availability zone but into another availability zone. So in last slide we discussed that we have different hardware racks. So not in the hardware rack within the same availability zone, but into separate availability zone. So in case this whole availability zone goes down for some reason, maybe network goes down, maybe the security system or the cooling system or something happened to this particular building, your data is still saved because it is saved in the separate availability zone. Now let's discuss the third one, which is Geo Redundant Storage, and this is part of our secondary region storage. So if I go back to my slide earlier, if you remember, here we discussed that redundancy in a secondary region. So now first 2 option was for the primary region, locally redundant and zone redundant. Now we are going into secondary region. So let me go back to my slides here. So now we are in the Geo Redundant Storage. In this, as you can see, our data is copied not just one rack within hardware rack of the same availability zone, not just in another availability zone, but into a separate region altogether. Now in Geo Redundant Storage, your data has 2 copies within the same availability zone, and your data also have 3 different copies into different region altogether. And this region, as I said, may be hundreds and thousands of miles different from region A. So in case of some natural disaster, if your whole region 1 goes down, your data is still saved in region B. Now if you have noticed, in this Geo Redundant Storage, there are 6 copies of your data, 3 copies within the same availability zone, and 3 more copies in the region B availability zone. When you select Geo Redundancy Storage, you does not get any option to select region B. This is selected by Microsoft, and this region, as I said, generally are hundreds and thousands of miles away, but mostly in the same country. So if you have region 1 in the West US, this may be in the East US, or if region 1 may be in the Central Canada, this may be in the East Canada, but generally it remains in the same country. Alright, so let's move forward, and the next one we have is Geo Redundant Storage. Now in this type of replication, your data is copied into different availability zones within the same region, and there are 3 copies of your data and 3 copies of your data stored in another availability zone of region B or secondary region. So as you might have guessed already, if your this availability zone goes down for some reason, within the same region you have another availability zone where we have the copy of your data, or if this whole region goes down for some reason, your data is copied into another region, secondary region, into one availability zone from where it can made available. Now the next point we want to understand here is that the secondary region data is not directly available to application without a failover initiated by Microsoft. Now what does that mean? If something happens to this region, if this goes down, then Microsoft will initiate the failover and Microsoft will make region B available for your application. But without failover, if something does not happen to region A, it is working fine as expected, your application cannot read data from secondary region. Now this is true for both Geo Redundant Storage as well as for Geo Redundant Storage. In this case also, data will be available only in case of failover raised by Microsoft. So now the point comes, if we already have data here, then why not it should be available for the application to read? In that case, the latency for users who are near to this region will be lower. So those users should be directly able to read data directly from here instead of going far to region A. And for that reason, Microsoft offered 2 new redundancy options. And first is read access Geo Redundant Storage. So if you see, it is exactly look like the Geo Redundant Storage, but the only difference is it is read access. That means without failover also, your application can read data directly from this region. So without region A goes down, without Microsoft initiate the failover, this data is always available for your application to read. That's why it's called the read access Geo Redundant Storage. And same is true for Geo Redundant Storage. It's a read access. That means this data is available for your application to read without failover, without your region goes down. Your users who lives near this region can directly read data from this region. So if I go back to my slide, first slide in this lesson, we have redundancy in the primary region, and if you remember, we have locally redundant as well as zone redundant storage where the data is stored within the same region, and then we have the secondary region storage where the data also copied into region B. And if you remember, we have 2 such kind of redundant option, Geo Redundant and Geo Redundant option. And then of course we have read access to data secondary region, and again we have 2 more redundant storage option here, and it is exactly like the redundant in secondary region, except here we have the read option available in secondary region. So I hope now replication options are pretty clear. Total we have 6 options, and we looked at all of these options in great detail. And as I said, they are important to understand. So if required, you can listen this lesson once again, but to make sure that you understand all of these 6 different replication options pretty well. Thank you. Alright, so in the previous lesson, we discussed about all of these different replication options in great detail. So I will choose locally redundant storage, which is the cheapest one and should be good enough for my demo. Now, Blob Storage also has a feature called access tier, and which has to do with storing your data in a way that's most cost effective. And it depends on how frequently you want to access your data. And you can see 2 options here, hot and cool. And there is actually one more option that is called archive, which we cannot see here, but once we create account, we can see that option and we can move data into that archive access tier also. So once again, we'll go to the slides to discuss hot, cool and archive access tiers in detail. Now first we have the hot tier, and hot tier indicates that blobs will be accessed more frequently, and this lets you store the data at a lower data access cost but higher storage cost. So if you choose the cool tier, this means you expect blobs to be accessed less frequently. So your data access cost is higher, but the data storage cost is lower. So basically it's a trade between storage cost versus access cost. If you think that your application is using data very frequently, you should use the hot storage, because here the access data cost is lower. But in that case, you'll have to pay more for the storage. But let's say your data becomes little old and your application is not as frequently as using that data. In that case, you can move your data to the cool storage. In that case, your storage cost will be low. And since you're not accessing your data very frequently, so even though the data access cost is higher, but as I said, since you're not accessing your data, so it should be fine. And there is a third type of tier that is called archive tier. In this archive tier, you have the lowest storage cost, but the highest data retrieval cost, and your data is offline. So that means when you shift your data into archive tier, it is not immediately available, even if you need it. Sometimes it takes hours, 5 hours, 8 hours, or even more than that to get your data back. But the storage cost is very cheap here in this archive tier. So let's say if you have a lot of data and you are almost sure that you don't need that data, but you still just want to keep it, for the future purpose, just in case if you want to see something, if you want to check something in data, then you can put that data into archive folder, because here the storage is very cheap and you're not going to access that data anyway. But as I said, the data retrieval cost is high here. So if you don't access this data, it is very cheap, just let it be there. But in case you need to retrieve that data, it will cost you a lot of money. Not a lot of money, but still it will cost you something. And as I said, data will be offline here. So if we understand in terms of blob storage lifecycle management, when your data is new, it generally more accessed by your application. So you should always keep that kind of data in the hot tier. And as it become little older with the time, your application may not need it. You may not access that data so frequently. In that case, you can shift it to the cool tier. And as it become very old and it's almost not usable, you can move that data into archive tier. And the good thing is you don't have to do this manually. Within blob storage, you can define the policy And according to that policy, you can define that, for example, after 18 months, move your data to the cold storage, and another after 18 months or maybe 2 or 3 years, move your data to the archive folder. And you don't have to do anything, and Azure Blob Storage will take care of this data. And as you define the policy, it will move data from one tier to another tier, and you can save a lot of money using this Azure Blob Storage feature. Alright, so we are back to portal, and now we can choose access tier as a hot, and we have filled everything else here, so we can move forward to the networking. And now here we have different options for connectivity. So we have 3 options for connectivity method. We can select either the public or private endpoint, and within the public endpoint we can allow access from all networks including the internet, or we can choose the Azure VNet we want the storage account to access from. Now if we choose a public endpoint selected network option here, this prevents access from the internet, so you can restrict access to only VMs or services on the VNets that you choose here. And this creates a very trustworthy boundary here. And we also have option to choose a private endpoint here. And this is a newer feature that allows clients on a virtual network to securely access data in the storage account over a private link. The private endpoint will use an IP address from the VNet address space, and this effectively brings the Azure service inside your private VNet and keep the access rules private. And this increasing security and lets you connect to storage account from on-premises networks that connect to the VNet using VPN or express route connections. And this is something we cannot do using the public endpoint, or even if you restrict access with your selected networks. So private endpoint ensures that traffic can flow from on-premises over a fully private path to Azure. In order for the private VNet to work, DNS record needs to be created, and you choose here whether you want to let Azure configure that for you with the private DNS zone, or you want to use your own DNS server. So I will discard it for now, and I will go back to the default option, which is public endpoint. And once again, this will allow you to have access from all the networks, including internet. But that doesn't mean this is insecure. Even you can access your storage from internet, but you still need credentials to to log in or to access the storage account. Now the next option you have is the routing performance. This means that you want to specify how network traffic is routed to your storage account from client over the internet. You want to use Microsoft network, or you may have your own maybe premium network you want to use. So it depends. If you have high performance or maybe low cost network which you want to use, you can configure here. But anyway, we are going to choose the default here and move forward with the data protection option. And then we have Blob soft delete. Basically this provide kind of recycle bin for your blob. So if you delete your blob by mistake, you can recover it back from the recycle bin. And this is same for the file type of your storage account. So we can leave it as a disable for this demo and move next to the advanced setting. And here the first option we have is the secure transfer required. So the default setting of secure transfer required is enabled. That means when client is trying to access this account, they're supposed to use HTTPS protocol. You can see here when calling the REST API to access your storage account, you must connect using HTTPS. So this is enabled by default. We can leave it enabled. And the next one is Blob public access. That means if you want to make your blob publicly available without using of any access key or SAS key, or in fact any credentials, you can use this feature here. So sometimes, for example, you want to save some file and you want that file to be publicly available for anyone and everyone. You can enable this here, but for this demo we can leave it as a default. And here we can choose the minimum TLS version which your client may want to use, and again we'll leave it as a default as a version 1. And here we have an option to choose the large file share. So we can enable large file shares for the file service, and this allows file shares to scale up to 100 terabyte. And this is disabled and we are fine with that. This is important setting here, hierarchical namespace. So basically if we turn on hierarchical namespace, this allows the storage account to be organized into a nested directories, and that's used when we want to leverage the storage account for data lake storage. So if you want to convert this account to data lake storage Gen 2 account, all we have to do is to just enable here, and this account will become Azure data lake storage Gen 2 account. And we will discuss this setting in detail in data lake section. So right now let me disable this and move forward with the tags, and I don't want to assign tags right now, and as you know we can do it later if required. So I will go ahead and click on review and create. Alright, so we can quickly review all the settings here which we have chosen while creating this account. So we have replication as a local redundant and standard performance. Access tier is hot. Publicly endpoint, we were choosing the connectivity method, and everything else looks good. So I can just go ahead and click on create. Now it may take some time here for the deployment, maybe a few minutes. So let me stop my recording here and I'll be back as soon as the deployment completes. Alright, so my deployment has been completed, and let me click on go to resource. Alright, so this is disabled for some reason. Let me refresh this. Okay, this is something unusual. So you see here we have our deployment succeeded. Let me click here. Alright, so this become enable, or otherwise we can just directly go from here also. But anyway, so let's go to resource, and right now we are inside the brand new storage account. Let me collapse this window so that we get a little bit more space here to look our account. Alright, so once again this is a little unusual here. Alright, so right now I am inside the overview page, and here you can see all the settings of this account. Right now we have a locally redundant replication, we have version 2 account, we have standard performance and hot access tier. Right now account is available, location, subscription and tags. We did not choose tags while we creating this account. If required we can choose it here. And then if you go below a little bit, you can see all 4 types of accounts here. So as I said, this is the storage account, but we can create file types, table type, queue type or blob type account or storage right within this account. And of course we can have more than one type of storage within this same account. So if you go down here, we have the different SDKs and different languages through which we can access this account. And if we go a little bit more down here, we can have different monitoring charts here. Since this is a brand new account, so obviously everything is blank here, but once we have activity here, we can see different monitoring related charts here. Alright, so let's scroll up once again, and here we have a couple of more options. For example, if I want, I can open this account into Storage Explorer, and Storage Explorer is a separate desktop tool. It's a free tool, you can download it, and you can open this storage account within Storage Explorer, and then you can move this storage account into different resource group or subscription, and of course you can refresh or you can delete this storage account. So after overview, we have activity logs. So in activity log, we can see all the changes made into account and who made the changes and what is the status of that change. For example, we have just created this account. Who created this account? What is the status? How long? What is the time when this account was created? Under what subscription? So let's say if someone changed the access key of this account or the replication or maybe some other configuration, we can see all that in logs here within activity logs. And then we have access control or IAM, identity and access management. In this we can assign the role to this storage account, and we're going to discuss this in detail in maybe security section, but very quickly we define these roles in Azure Active Directory, and then we can add these roles here for the storage account, and we have different roles here, and depending on what level of access we want to give to someone, we can choose one of these roles, and we can assign that role into the user or even the service, that's if any service wants to access the storage account. And then of course we have tags here. We can assign more tags here. And then here we have some Microsoft related documents. If you're having some issues with the storage account, you can come here, and they have provided different troubleshooting options. Maybe this is the first place you may want to take a look if you're having some issues. And then you have data transfer options here. So depends on what kind of or what is the size of your data, you can choose here, and what kind of network bandwidth you have, and what kind of transfer frequency you have. It is just one-time transfer, or you transfer this frequently or repeatedly, and you can choose here. And Microsoft Azure give you different options. You can choose this data to your Azure storage account. If you're using storage account first time, let me tell you that it is not that easy. Azure has provided different tools to handle different kind of situations and scenarios and different data size. So you may be aware of all these tools, but this is very handy tool. You just choose here what kind of size you have, your network bandwidth, your what kind of transfer you want, and Microsoft will suggest you different tools which you can use here. And then next we have the events here. So this is the event routing service here, and this lets other service respond to the events in a published subscribed model. So let's say if there's any event here, for example, if you upload any blob here, you can create an event, you can define an Azure function, and you can take any action on that. And this event grid can collect events from many different services in an Azure, and storage account is just one example. And then we have Storage Explorer here. Earlier this used to be a separate tool, but now Microsoft has integrated it right here, and you can see that this is still in preview, and you can access your different storage accounts from right within the portal from here. And then we have access keys, and if someone has these access keys, they will be able to access your account. So this is very secure. And we have Geo Replication option here. So you can see that right now our account is locally redundant. So we are right now in the West US. And if we choose other redundant option, we can see that in which other regions we have our data replicated. And then similarly, we have some other security and configuration, options here. So we'll look at all these options in detail sometime later. Let me show you in properties. So in properties, you can see the REST endpoints for this service. So for example, for Blob service, this is the address through which you can access this service. For queue service, this is the address, and you can see it's almost same, except the fact that here we are using the blob and here we are using the queue. Other address will remain same, and same is for the table here. Now we also can look at the configuration here. In configuration, we can see some of the settings we selected while creating this account, and if required, we can change those settings here. For example, secure transfer, we can disable it. Public access, we can enable it if required. We can change the access to your replication. You see we have replication option here, and if required, we can change it right from here. And then we have we see that our data lake gen 2 is disabled, so this is not the data lake account here. This is the blob account or general storage account here. And then we can go down and we can see here we can access our blob containers from here, and we can add our containers here if required. And this is to access our file storage, table storage, and queue storage. And if we go further down, we have the monitoring options here, different metrics and alerts and all, and we will look into this later in this module. And then we have some of the supports and troubleshooting options here. So this was the quick overview of the storage account portal. I hope now you are a little bit more familiar with the storage account now. Thank you. Azure Blob Storage is an object storage solution that is optimized to store massive amount of unstructured data like text files or image files or video files, any kind of document or binary data. You can in fact even store virtual machine images or in fact database backups also in the blob storage. So basically you can just about to put anything inside of this blob storage. So as I said, this is designed for unstructured data. For example, you can upload several documents to Azure Blob Storage and access them directly by the browser. And you can also use Azure Blob Storage for data backup and other storage purposes. Many Azure services, for example, Azure SQL Database, are storing their backups into Azure Blob Storage, and these backups can be kept for up to 10 years. And then we have audio and video files that can also be uploaded into Azure Blob Storage, and clients of these files can access and stream them directly from Blob Storage. Also, this service can be used to store data for analysis. For example, you can store a huge amount of raw data in the Azure Blob Storage and configure Azure Stream Analytics to access and analyze this raw data. The output of Azure Stream Analytics can also be saved into this Azure Blob Storage. And both manual application log files and Azure log files can store into the Azure Blob Storage. Also, Azure Blob Storage can automatically scale when the demand increases. And as we know, this is the cheapest way to store data in Microsoft Azure. It has a very simple design and it's very easy to use. And the nice thing about this is there's a lot of things going on behind the scene to give you geo redundancy, to make it accessible and to provide a user interface that is simple to use and very intuitive about how you can use this. It has an HDFS and blob storage REST APIs, meaning that it could interact with a lot of different programs. There are three types of blobs you can store: block blob, append, and page blob. Let me go to my portal and show you how to access these different types of blobs. So right now I am inside my blob, and if I go to the container here under blob services, and let me create some sample container here, maybe just demo. And if in this container I try to access some file here, you can see if I go to the advanced options, I can select the blob type. So whatever file I will select here to upload, I can choose different blob type for this file to get stored: block blob, page blob, and append blob. And in this section you can also see that you can also change the different tiers to store this file into, and you have archive access tier here also. So let me go back to my slides and continue discussing. So the block blob can store your text or binary data, and the size of this single blob can go up to 4.7 terabyte. And this is called block blob because one single blob is made up of many blocks, and this is helpful in optimizing your uploading of your data. And then we have append blob. Append blob are made up of blocks also, but they are optimized for appending data only. So they are good choice for logs where you only need to add into a file. In fact, you will see later that append blob are used by blob change feed logs. And then we have page blob. Page blob is generally used to store disk for virtual machine and databases, and they are generally used for frequent and random read-write applications. So they are foundation of Azure infrastructure as a service disk. So both the OS disk and data disk are stored in page blob. So Azure SQL Database also uses page blobs as a persistent storage for its databases. You could also leverage page blobs yourself for something like shared media access for collaborative video editing, because page blobs allow for fast access to random locations in the media and for merging of the same media by multiple users. So let me go to the next slide, and here we have some use cases for the Azure Blob Storage. So Azure Blob Storage, we can use this when you only need some basic storage, when your data is unstructured, you have data that is older but not as much in use. So you have some kind of information that needs to be kept but not analyzed or queried anytime soon. You can keep all those data here. And of course, this is very cheap. So if finance or money is an issue, you can consider Azure Blob Storage. And it has some of the advantages. For example, it's extremely cheap. When I say cheap, it is probably the most one of the most cheapest service, I would say, in Microsoft Azure. It hardly charges 2 cents for a gigabyte of storage or file. So you can just dump your data into Blob Storage for later processing, even if you don't require it now. And it is simple to set up. All you have to do is just create a container and just upload data, and that's it. You do not need a lot of different steps to set up your container. And then there is not really a lot of configuration required. You are not having to make a lot of decisions, and it doesn't require any computing. All you have to do is just manage the container, and it does not require a powerful computing to manage. So it's like a container. It's like a box where you just dump your data without thinking about computing or any other configuration. So it has a lot of advantage for its simplicity as well as its low price. And then we have some limitations of Blob Storage. Of course, it does not have an index or the search tool. So if you have a lot of files into Blob Storage, sometimes it's difficult to find your particular file you're looking for. And it is not optimized for performance. And later we will see that how data lake, which is built on top of this Blob Storage, is optimized for performance. So we use the data lake if we are looking for performance. And as far as replication is concerned, Blob Storage provide a few options to replicate our data but we are responsible to make sure that we choose the right option and choose the right replication option and redundant our data into different locations. And as we discussed, Blob Storage does not have its own compute, so it's just a storage service, and if any kind of compute required, we need to use other Azure services for this purpose. So this is all about Blob Storage. Let me go back to the portal and just show you a few more options that may be helpful to you. Alright, so I'm back to portal, and right now in few minutes back we created this container demo. So let me upload some file here, any small file, and you see, as I told you, we have the advanced options here. So I will not change these options here, but you know, access tier hot is fine, block type of blob is fine. So I will just go ahead and upload this file very quickly. This is the small file, so it uploaded very quickly. Now, if I choose this file, I have few options here. For example, I can acquire the lease. So acquiring lease means no one else can change this file now. I have a lease on this file. In fact, if I need to update this file, I need to use this lease ID while editing this file. And you know, when I'm done with this file, I can just break the lease so that this file is now available for everyone else to edit. And for this particular file, we can change the tier also. So as I said, we can use a particular tier. I mean, we can change this tier for individual files, and you can see we have that option here. And you can see that for individual file here, we have option to change access management and provide the access policy. So basically at the container level, we can change a lot of configurations here, or at the file level, in fact, we can change some of those configurations. So this was all about Blob Storage. I hope now you are a little bit more familiar with Blob Storage. Thank you. In this lesson, we are going to talk about managing data lifecycle. Managing data lifecycle is a fantastic way to both save your money as well as increase your data quality. So when we talk about managing the data lifecycle, actually we are talking about the Blob Storage. So if you remember, we have three different access tiers in Blob Storage. We have the hot tier, cool tier, and archive tier. Let me go back to a portal quickly and show you all of these three tiers. Alright, so I'm into my Azure portal now, and on the left hand side I have a shortcut of storage account. And if I create a new storage account here, so when we create a storage account, we have to choose the access tier for the storage account, whether cool or hot. We do not have archive tier here. But if I go inside my storage account, this is my another storage account I have. And if I go to, let's say, container here, and if I open one of the container, for example, the input container here, and if I choose one of the blob here, I can change access tier here. And I have all three options here, hot, cool, or archive. Similarly, if I upload the new blob here, in the advanced, I can choose to have hot, cool, or archive tier for this particular blob, which I'm going to upload. Now let me go back to my slide and explain once again what are these tier means. Alright, so first we have the hot tier here, and we use hot tier for those kind of blobs which we want to access very frequently. Because if you see here, we have the lowest data access cost. So there is almost no access cost or very low access cost. So we want to access data very frequently, almost on the daily basis. That kind of data we keep here. But at the same time, we have the highest storage cost. So we cannot keep all the data here. We only want to keep the data which is frequently accessed by the application. Now, when we see the cool tier, we have the lowest storage cost, but higher data access cost. That means we want to keep data here, which is not very frequently accessed by the application. Maybe we want to access periodically, once in a while kind of thing, but not very frequent. It's very infrequent kind of data we keep in the cool storage. And if you look at the archive storage, we have a very deep discount in the storage. It's very cheap. You can keep all of your history data in the archive tier if required. But at the same time, there's a heavy cost involved if you try to retrieve that data. In fact, the data is offline. You cannot retrieve, you cannot access it directly. You have to rehydrate it. You have to move data first to the cool or the hot tier in order to get access from the archive tier. But on the contrary, you will get a lowest storage cost. You can keep all your history or all your old data into archive tier. Now the idea is why we have these three tiers, so that we can save some cost in the storage, as well as the quality of data, the frequency, the speed, the latency of the data can also be improved. And maybe when data become little old, maybe 90 days old, when the application is not need to access it so frequently, we can move that data to the cool tier. And maybe the history data, maybe the data becomes, let's say, 1 year old. After that, we can shift to archive tier because we know that application is not going to access this data very frequently. So this is the life cycle management of the blob storage, that how we can move data from one tier into another tier, and we can save the cost, and then we can increase the data quality. Now, we don't have to do this manually. We don't have to manually move data from hot to cool or cool to archive. We can define the policy, and based on that policy, Azure will shift this data from one tier into another tier. So lifecycle management is a policy that you can set that allows you to transition blobs from the cooler storage tier automatically to the archive tier. And this is again to optimize the performance and the cost. And not only move the data, it can also delete the blob at the end of their life cycle. So you can also build governance rules so that you are ensuring data quality and you are ensuring the governance that you need with the files that you have. So basically the lifecycle management is something that you set to container, and so any blob that goes into that container would be governed by these rules. It's pretty easy to set and configure, and it doesn't cost anything. So it's free of charge. So let me go back to a portal and show you, give you a demo how we can set this lifecycle management policy. All right, I am once again into my blob storage account now, and let me choose this blob here and change the access tier here, and I can change this to, let's say, archive here. Let me archive this, and you see this error, message here, warning message here, that setting the access to archive will make your blob inaccessible. So you will not be able to access it after that. And we have to rehydrate it back either to the hot or cool. And this can take even several hours, So let's save this to the archive folder, archive access tier, and it may take a few minutes because this is very small file. It's just 685 bytes. But meanwhile, I also want to show you something else. So let me go back to my blob storage here, and if I go to the configuration under setting here, let me go to the configuration, and you can see here that we have the default setting for access tier, which we choose while we creating this account, and you can change it. You can change it to the cool, or you can leave it to the hot. And this setting is for entire account. That means all the container and all the blobs inside the container will have default access tier. And if you want to change the access tier for individual one, as I showed you, we can go to the containers and then particular container, and then we can select and we can change the access tier. And you can see that the access tier we just changed few seconds back for product category has been changed to archive. Now, if I try to access this, if I try to view this blob, you can see that it is not available. In fact, if I go back and if I try to download it, I will not be able to download it also. You can see that we have error message here. The XML file does not appear to have any style information associated with it. The document is shown here. So we cannot download it. If I click it here, in fact, you see that you will see that our download option should be disabled because this file is now part of the archive access tier. It is taking some time. Let me try once again here. All right, so now you can see that our download option is disabled here. And once again, if I go to edit, I cannot see this file here. Now let me move this file back to the hot or cool tier so that we can access it. So once again, I select this file and I come here and I change the tier here, change tier. And once again, I can change it back either to hot or cool to access it back. So let me change it to hot. And here we can see that rehydrate priority. So this is basically how much tolerance you have for delay to get it back to the hot or cool. So let me keep it standard as of now and save it. And again, it may take a few seconds for this file to, bring it back to hot tier. Now let me go back once again to my blob storage and let me show you this lifecycle management which we are talking about under blob service. So let me select the lifecycle management, and here you can see that I can add a rule or kind of policy here to move data from one tier into another tier. So I can say, for example, blob rule maybe, and then we can have a status as enable, and we want to move data to cool storage from hot, maybe let's say after 90 days or maybe 30 days, I would say after a month, depends your application. And from cool, I want to move it to the archive once again, maybe after 180 days. And ultimately I want to delete these blobs maybe after 1000 days, let's say. So after 30 days, these blobs will move to the cool storage, and after 180 days to the archive, and after 1000 days, these blobs will be deleted. And here we also have option to select the snapshot, that you can create the snapshot of the blob which you can delete after a certain number of days. I'm not selecting it right now here. So let's move forward to the filter set, and here we need to choose our blobs or the containers on which basically we want to apply this policy, this rule. Now here you can browse the container on which you want to apply this rule. So for example, I want to apply on ADF input, and if you have a lot of containers here, of course you can filter it from here. So let me select the ADF input. Now virtual folders within ADF. So we know that we do not have containers inside container within blob. Blob is the flat structure where we can only have a containers, but the folders within ADF input means what kind of file structure we have. So you know that within blob we save files like project1/file name or project2/different file name, and project becomes basically the folder. It reflects the folder even when it is not. So basically here you can filter the blobs on which you want to apply this policy. You can enter the prefix, and all the files starting with that prefix will have this rule. But let me select the entire container as of now here, and let me select. And another message I want to take your attention here is that if you do not select any filter, if you do not select any container here, this policy or rule will apply on all the containers and all the files. But now since we have selected this particular container, it will apply only on this container. And I can just go to review and add, and I will click on add, and I have just created this life cycle for my container input, ADF input here. Now all of these blobs will have this rule, this lifecycle management policy applied. Now you can notice here that it has already been passed few minutes or few seconds at least, but my access tier of this file has not changed yet. So as I said, it takes time to get this file back from archive folder. So you want to make sure that you do not save data in the archive folder which you may need immediately in some time. Let me go back to my blob storage once again, and let me go back to lifecycle management, and I want to show you here this code view where you can have this JSON code, and it's pretty simple. You can see that tired to cool after 30 days and to archive 180 days. So it's pretty simple code, and if you have this code you can just directly paste here and apply, and you can have the settings. And as with all other services. Lifecycle management you can do not just with Portal, but you can use the PowerShell, you can use the CLI, you can use the ARM templates, or you can use the SDK. So by all other means, you can have this setting in place. And the last thing I want to convey to you, that these lifecycle management rules not immediately applied. It may take 24 hours of time. So basically every 24-hour cycle, these rules apply to these containers. So if you are coming back, let's say after a few hours, and make some more changes, it may or may not go into the same cycle. You may miss the cycle, and then again after 24 hours, when the next cycle comes, your changes will be applied to the container. So I hope now lifecycle management concept is clear. And of course, if you have hundreds and thousands of container or hundreds and thousands of blobs inside this container, you cannot do it manually. And this is how this concept lifecycle management has come, where you can apply the policy or the rule at the container level or at the account level, and you can manage all of your blob, all of your data, and you can get the more efficient data, and you can also save some cost by efficiently moving this data from one tier into another tier. Thank you. Hello friends, welcome back. And in this lesson, we are going to discuss about high availability and disaster recovery options for Azure Storage Service. Now, before I move forward, I want to make sure that you have gone through another lesson where I have described in detail about redundancy options like local, zone, or geo redundancy option. Because we are going to analyze the same redundancy option here to see how they can help us set up highly availability and disaster recovery options. All right, so let's move forward. Let's start with the LRS, locally redundant storage. And in this, we can see that our data is replicated into a single physical location. So if there is some issue with the node, we still have the replicated data. So our application can keep working if there's a problem with a single node. But if there's a problem with the whole availability zone here, then our application may goes down. So our application is available, but within a single physical location. If I move forward to the zone redundancy storage, we can see that our data is replicated into different availability zones. So this is basically a true availability, I would say high availability. Because if one zone gets down, we have replicated data into different zones. But still, if the whole region goes down, our application will also goes down. So this support high availability, but this does not support disaster recovery, because disaster recovery means even if the region goes down, my application should be able to recover. So let's move forward. So the first true disaster recovery option we have is Geo Redundant Storage. In this case, even if the whole region goes down, I still have region B where my data is replicated, so I can recover my application. So Microsoft recommend minimum Geo Redundant Storage for disaster recovery kind of situation. So let's move forward, and here we have Geo Zone Redundant Storage. So this is better than GRS, because here we have the true high availability and also disaster recovery. So this covers the both options. So let's move forward. And now here we have RA GRS. In this case, region B always will be available for read. So even in case of disaster recovery, so even if the region A goes down, my application will be able to have read data access immediately without taking a time. But generally, I mean, in case of disaster recovery, it takes at least 1 hour or couple of hours before our application is up and running. But in this case, at least our application can read immediately, because this is read access GRS. And if I move forward here, I have read access Geo Zone Redundant Storage. And once again, this provides us the high availability option within the same region, and region B, we have the read option available. So this also covers the not only disaster recovery, but we will have our read data access immediately in case of disaster recovery. So if you look at this chart, I have copied this from Microsoft website. This is kind of compiled version of these options here. So if one node goes down, even LRS can cover that. Because within LRS, if one node goes down, we have another instance of the application. And of course, all other redundant option will cover this. Now, if the entire data center or the zone goes down, then LRS will not cover this. For that, we need ZRS, Zone Redundant Storage. But if the whole region goes down, then both of these options will not cover that. For that, we need minimum GRS, and that's why GRS or RAGRS or other redundant option, they will be able to cover our this disaster recovery kind of situation. And as I said, with the RA, we also have a read access. So in case the whole region goes down, we still have the immediate read access to our application using RA, ZRS and RAZRS option. So now the question comes, what we are supposed to do if the region goes down. Now what to do? Are we going to have auto failover? No, we have to do manual failover as of now. At the time of this recording, there is no auto failover. So let me go to the portal and show you how we can initiate the failover in case of region unavailable. All right, so I'm into my storage account right now. And if I scroll down a little bit here, I can see configuration. And if I go inside the configuration, I can see what is my current replication configuration for this storage account. And you can see that I have Geo Redundant Storage. That means my data is replicating to some other region, to the secondary region right now. And of course, you can change your replication here if you want. So now let me go to the Geo Replication option here. And you can see that my primary location is Central US and my secondary location is East US 2. So for some reason, for some kind of disaster, if my Central US location goes down, I can come here on this storage account to Geo Replication and I can prepare for failover. So if I click here, I can read here that my storage account secondary endpoint will become my primary endpoint after failover complete. So the East US 2, which is right now secondary location, will become the primary location. And another important setting here is your last sync time is 9:18 and 4:36 PM. That means this was the last time when my data was synced from primary to secondary. So after this time, if there was any change in the data, I'm going to lose that change. I'm going to lose that data, that changes to my data. So this is called last sync time. This is important property. And that's why we say that in case of disaster recovery, there is a possibility of losing a data. So all I have to do is just type here yes and just click on failover, and it will take some time, and after that time my East US 2 will become my primary location. And once again, as being in the primary location of East US 2, I can again set up my Geo Redundant replication option, and my data can be replicated to another region which is up and running. All right, so this is good. And before I go back to my slides, I want to show you another very important setting here. So if I scroll down under Blob service, I have data protection. If I go here, I can see that I have option to turn on soft delete for blobs. So what is that? That is, if by mistake you make some changes in your data or you delete some of your data, if you have this setting enabled here, you can recover that data within this period of time. So right now by default it is 7 days. So for last 7 days your data will be still saved. All right, so let me go back to my slide and then we can summarize what we all discussed in this lesson so far. Alright, so let's discuss what you're going to do if you're going to face some kind of Azure Storage outage. So first of all, one of the things you can do if you are utilizing Azure Storage, and that's a big dependency for your application for detection, you can subscribe to the Azure Service Health Dashboard. And so basically it is just a web page, and it's got an RSS feed. You can go in there and subscribe to that feed, and you'll be notified anytime there is any kind of service issue. And of course, in particular, you'll be looking for Azure Storage related service issues. So for detection, that's the kind of step one. Now, depend on what kind of replication type you have configured. You have got a couple of different options when it comes to recovering from an outage. So if you just did LRS, or locally redundant storage, or ZRS, zone redundant storage, you may have to wait for recovery. That is the only option you have. Wait for the Azure service team to resolve whatever issue it is, and wait for your application data to be available again in Azure Storage. So you just have to wait. Now let's say you have ZRS or RAZRS or further advanced option. The first thing you can do is manual failover. And I just showed you in the portal that how you can go and enable the failover, and it may take a couple of hours. You may lose some data, but your secondary site, secondary physical location will be up and running, and your application will be able to connect with that and will be able to continue whatever business it does. And another option you have is actually you can also copy data from the secondary region to another region, and that's functioning is get to your application data. So you can copy data out with the tools like AZ Copy or Azure PowerShell or Azure Data Movement Library, and you can copy data from this secondary location to some other location which is up and running, which does not have any issue, and you can connect your application to that storage infrastructure. So that is the another option you have. So make sure you remember that Microsoft recommend to have at least ZRS, or more preferably RAZRS replication option. In that way, if there is any regional outage, your application will be able to connect with your secondary location immediately, and at least your application will be able to read that data. And once the failover complete, your application will be able to up and running functionally, fully functionally, with the second physical location, which actually will become your primary location. So I hope by the end of this lesson you have a fairly good understanding about high availability and disaster recovery options for Azure Storage account. Thank you.